Aloha, Richard Halverson here. This is ITS148, and today I'm going to do our lab 17.6 merge sort. So let me share my screen. And so it's lab 17.6, and we are implementing, this is the merge sorts section, our 17.2. And you should read through this because what we have over on this side is this is the actual working program that they give you here, down here. It's this program, except for it's modified so it reads in input. And all you have to do is to count the comparisons. So what does that mean? Well, if you go back here and see how merge sort works, you should read this, but basically, with merge sort, you have two sorted lists that you want to merge together into one sorted list. And so if this list is sorted and this list is sorted, it's pretty easy. You just start at the top, and if you're going smallest to largest, then the lists are smallest to largest, and then you look at each of the top and you pick the smallest one, put that there. You look at the next ones, pick the smallest one, put that there. Next one, smallest one, pick that there. And so each time you do one comparison, because you're comparing two of the elements from the two different lists. Each time you compare, you add another element to the sorted list. And so if you look, the way the algorithm works, of course, it's recursive. This recursive version is it starts by splitting each. It starts with the whole list, and it splits it into two lists, and it splits it into two lists, and it splits it into two lists all the way until it gets just one element in each list, and then it turns around and it starts merging back up again. If you have two elements, if you have one element in one list and one element in the second list, then you just take the smallest one, and that's the first one, and then you take the next one, and that's the next one, and then over here this was only one element, so it's already sorted, and so then you have a sorted list and a sorted list, and you combine that into another sorted list. And so first it's going to compare the 3 and the 8, puts the 3 there. Then it's going to compare the 11 and the 8. It's going to put the 8 there, and then all that's left is the 11. It's going to put the 11 there. And then you have these two sorted lists here, and you do the same thing, and you end up with a sorted list, a one sorted list. So the comparisons are when this is compared with this, when this is compared with this. So we just need to go over here and this is the sorted. This is the program. And well, first of all, I'll tell you what, let's run this program to see what we got. Okay, they've given us a completely fine executing program. It says the program is the same shown at the end of the merge sorts section with the following changes. It's made it so you can read, so it's made it so the program reads in the numbers to sort from the user instead of defining a specific list. The output of the list has been moved to a print nums method, and an output has been added to merge sort, showing the indexes that will be passed to each of the recursive calls. So if we have this, so here we have the unsorted list and the first, and so the 0 and the 2 are compared with the 3 and the 5 and so on. And you can see that you can look at this closely and understand what's going on. I'm not going to do that right here. I'll probably confuse you. So I'm going to copy the data, the input, and I'm going to put it down here into where we would put it if we were to run it. And I'm going to click run program. And this is what we get to start with. It looks just like Um, looks just like this. And all we have to do is figure out how many comparisons there were. So, um, so we just need to add in this code counting the comparisons. And does it give us a hint? Hint, use a global variable to count the comparisons. Take special care to look at the output of each test to better understand the merge sort algorithm. Okay, so that's what you want to look at when you're doing this. So, all right, so a global variable. All right, so I'm going to start at the top here, and I'm going to put this over here. I'm going to put a variable at the top called comparisons. And I'm going to say that's equal to 0. Okay, so that's going to be a global variable. And so wherever I increment the comparisons variable, I have to put that global statement up at the top of that. And there's a read nums. This is where reads a number. Let's go down to the starting down here. Okay, so it starts out, this is a loop. This is the loop where it outputs, these are indexes. These are indexes. And so because it's one list. And so here in this, in the array numbers from starts out j is equal to 0. And no, it starts out I and k. So j is equal to 0, and the range is wait a minute. This is where it starts. Merge. This is the array. Merge sort. This is the 0th index, the very first element, and this is the very last element. So that's the list. That's the list to sort. It's an unsorted list, and that's a list to sort. And it's returned from this function called read nums, which I hope returns a list. This is going to be a list if it does that. So return, this is a list. So it returns a list. That's in brackets. So it's an integer list that was input. And that's what's returned when this function is called. So that's what we have here. And this prints it out. And that is what we see right here. Unsorted list. That's what we see right here. Unsorted list. And then we call merge sort, and this is the index. This is the 0th element, and this is the how many other 1, 2, 3, 4, 5, 6. 6 minus 1 is 5, so it's 0 and 5, and it comes into here and is 0 less than 5? Yes, it is. So it figures out what the middle is, and it prints out middle plus 1 and 5. And is that what it printed out here? It printed out, 0, and then the middle one, and then the middle one plus 1, and then 5. So with a vertical bar in the middle, that's this vertical bar. So this is the 0 and the 5 that came in, and this is where it's split in two. Okay, and so then it's gonna call and you know, because I is less than K, then there's something there. So then this does this splits it into two and sorts each individual portion half, sorts each individual half until I is not less than K, in which case it just returns. So that means it's already sorted. So if I is equal to K, then there's only one element in the list, and a one element list is already sorted, so it can just return, and it comes back here, and it merges the two lists together, which is doing. Okay, so first it splits it all the way down. It doesn't do any comparisons until it splits it all the way down into these one elements. And then as it's building it back up again, it's doing the comparisons. And so that's where this comes in. That's where this merge comes in. And the merge is this program here. And so we're merging two lists. The bottom half of the list is between here and here. And that's one list, and the other list is from J plus 1 to K. That's the other list, and we got to merge those two together. And we're going to merge them into another list. Okay, so this is where the merge sort needs double the amount of space. It's the space is OVAN, whereas in other algorithms it's not, or something. Anyway, so here we're going to go through the full size, which is from here to here, and we're going to each time do a comparison. Yeah, we're going to start with the 0th one, and then we're going to do this loop. This is the left position, this is the right position, and we're going to do this. And here's where we do this comparison. While the left position is still is less than or equal to as high as it should go, and the right position is less than or equal to as high as it should go, then compare the left number with the right number, and you want to take the smaller one and add that to the new list. And so merged numbers is the new list. And so if the left one is smaller than the right one, in other words, if this 3 is smaller than this 4, that's what we're doing, comparing two things. This is farther up. Then you want to take the smaller one. You want to take the smaller one and add that one to the merged array. And then you want to increment the left one. So after you add 3 to the array, then you got to increment it. And now we're going to be pointing to this one because we've already done this. So we're pointing to this one, while on this side, we're still going to be pointing to the 4. And then the next iteration, the 8 is going to be compared with the 4, and then the 4 will win. So the 4 gets to go up here, and then the right position bumps up to this 18. And then after that, we're comparing the 8 with the 18, and the 8 wins, and so on. So that's what's going on here. So either the left position wins or the right position wins, and then the merged position increments by 1 because we got to. For each comparison, this gets incremented by 1. For each comparison, it gets incremented by 1. And then after we're done with that, we're going to have a bunch left over in one list. Okay. This is going to go until one of them runs out. And so if that one that runs out, you get to take all the rest of them that haven't run out. That's a sorted list, and it's going to go. That just gets added on to the end. And so that's what's going on here. If there's anything, here if there's anything on the left, it gets, those just get added in. It's either going to be this one or this one. It's not going to be both, so it's either this one or this one, and then here, this last thing, we take everything from this list that we created, and we copy it back over into the main list. starting at the positions, starting at the ith position, see, so because we could be, sorting some small portion of this whole big list. And so anyway, so where does the comparison happen? Well, the comparison happens right here. So I think we can just put right here, we're going to put comparison, we can increment comparisons here. And here we have to say, up at the top, we have to say global comparisons. Okay, that means that this is global because really it's this variable here that we want. We don't want it to be a new one down here. If we didn't put this, then this would be this one would be different than this one out here. Okay. We want them to be the same. All right. Has to do with scoping. So, and then at the end, I guess we want to print out comparisons. Comparisons equals comparisons. Okay, so at the very end down here, I'm going to do print I wonder how this ends. All right, I'm just going to try this and see how it ends up. Comparisons, colon, quote, comma, comparisons. All right. Let's see. All right, I'm going to run this. It looks pretty wrong. I wonder why it's wrong. 3, 2, 1, 5, 9, 8. Comparisons equals 5. Yeah, the problem is, I see, is that I'm counting how many times this whole thing executes. And this whole thing's just going to execute once each time merge is called. I'm actually counting how many times merge is called. I want to count how many times we're inside here, because this is the loop, and this is the comparison. So this is the comparison I want to count. It's not this comparison. Okay, so really this should be here. Okay, so now I'm going to try it. All right, I think that works. Is everything right? My solution is different than the book textbooks solution. So I noticed that this is a lowercase c, and mine is an uppercase C. So anyway, you may have to fix that. Anyway, so that 17.6. Hope this helps. Thanks for watching.